Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back to work on our little Nobsound 6P1, and today we're going to address the problem with the power supply, and it's a twofold problem. The first one is, and I know I keep repeating this, it's got a 110 volt wound power transformer. And so we're going to have to come up with some way of dropping the input voltage to the correct voltage. And obviously, if you live in a country where they have 110 volts, it's not an issue. But in the US, most of our outlets are 120 to 125 almost in some places. You can measure it and you can see what it is where you live, but we need to drop that down to 110 volts. And so in another video shortly, I'm going to show you how to build a bucking transformer. I'll put a link below to a website that explains how that works. So we're not going to get into that in this video. What we are going to talk about is the filtering capacitors that they put in this amp and why they're a problem. If you look up the data sheet for this rectifier tube, it specifies that the first filtering capacitor should be a 5 UF capacitor. And they installed a 150 UF capacitor, which is hugely too big for a tube rectified power supply. Why they did it, I have no idea. Maybe they just got a deal on those big capacitors, or they thought, hey, this will do something good. I don't know. But anyway, that's what we need to address today. The other thing is there's no bleeder resistor in the power supply. So when you turn the power off, the capacitors stay charged. And the output tubes do continue to draw some current and help pull it down, but there's still too much voltage there, especially if the amp gets short-cycled in any way. So we want to put in a bleeder resistor. We want to be cognizant of the fact that this power transformer is kind of on the edge of melting down, so we don't want to put in too low a value of a bleeder resistor and add load to this transformer that's already being overtaxed. And so we're going to use a 470K 1 watt metal film resistor, and then we're going to use a 22 UF 450 volt capacitor. And I'll be shocked if these parts cost $1. You know, the shipping's going to be way more than what these parts cost, but this is all we're going to be installing today. But don't go ahead and order these parts yet, because there's a couple of other parts that we're going to do in the next video that you want to order at the same time if you're going to be going inside the amp. So the first solution that I thought about trying without going inside the amp was to use one of these solid state rectifier replacement little gizmos. And this would be able to tolerate having the large first cap inside the amp. It would be a nice solution. But unfortunately, this brings the voltage up across the tube to 260 volts, which the amp might be able to survive that. These tubes are rated at 250 max, and 260 is just a little over. So if you don't want to go inside the amp, and the amp's eating rectifier tubes, you can try this. But I can't guarantee that the output tubes aren't going to end up overheating or sparking or working out or causing problems in the future. But I can't imagine 10 volts is going to be a huge issue for them. But anyway, I feel like that most people like this tube rectifier. This capacitor is probably a better solution. So we're going to do this route. And I'm going to explain quickly too why this capacitor is such a problem. And a lot of people think it's from the inrush current. And they're tempted to put a like a resistor to limit the current inrush, or put a thermistor in to help limit the current inrush, thinking that is the only problem. And that's not the case. So we have to think about what this tube is doing and how this capacitor interacts with it. And this is true of any tube rectifier. The AC is coming in like this. Nice big waveform. And so it's coming to the rectifier tube, and it's turning it into this, which is not what the tubes are looking for, but it's a direction of getting to DC. So the cap after the rectifier is smoothing out these lumps and making them more like this, right? And so the rectifier tube only passes current once that voltage gets below a certain point. If you have too big a capacitor after the rectifier tube, that voltage is going to drop off much slower, to the point that the rectifier tube is going, okay, I need to fill this cap back up. Well, in that process, the larger capacitor that's calling for voltage at a later point is shortening the window that the current is going to be passing through the rectifier tube. And if we're demanding 100 milliamps of current out of a 125 milliamp capable rectifier tube, and we shorten the window that current is allowed to pass through the tube, during that shorter window, the current is going to go up to possibly 200 milliamps. And especially with this large capacitor, that's highly likely what's happening. And so you've got the tube running over what its current rating is, which is stressing out the tube even after the capacitor is all filled up. And that's the reason that we're going to the smaller cap, is it's storing less energy between cycles, and so it's widening the window that the current demand is being sent to the rectifier tube, or current going through the rectifier tube. So I hope that makes sense. I didn't really understand that at first either, but after thinking about it, it really does make sense that these need to be sized to the current demand that's on the tube. And if you've got a circuit where the rectifier tube is, a lot oversized for the circuit that is pulling current through it, you can probably get away with a bigger cap than you can on a circuit that is pulling close to the max of what the tube can deliver. Now, I have experimented with this a little bit, and going down to a 5 UF cap, I did get a little hum out of the amplifier. And I think it's because it's only got one filtering section. It's got a cap, a choke, and a cap. And so to combat that, and the compromise is, instead of going down to a 4.7 UF, which is a common value near 5, we're going to use a 22 UF. And I really don't hear enough hum to worry about going to this size cap. So that's what we're going to be installing. The other problem with having giant caps like that is they do store a lot of energy, and without a bleeder resistor, it takes longer for the voltage to drop down if the amp gets short cycled. And by that I mean, like, turn it on, and then you go, turn it off, and you go, oh, I wanted to hear that, and you turn it right back on. Doing that can make the voltage that's stored in the caps arc across the rectifier tube, and once a rectifier tube arcs, it's done. Once the arc pathway is there, it's way easier the next time for the voltage to jump across that gap and arc again. And My experience, especially with the JJ5AR4s in a high demand situation, once they arc, the next time you turn the amp on, they arc, blow the fuse. Arc, blow the fuse, they're done. So we want to avoid that. These do seem to be pretty stout rectifier tubes, and they've got the right voltage drop for this amp across them, and they also are a slow warm-up so that the B plus comes up slowly, which is a good thing for the output tubes and the driver tubes. That it gives a chance for the heaters to heat the tubes up before the B plus comes in. So that's a bonus of this tube that comes with this amp. And so we want to keep this thing alive. And so let's jump into fixing the power supply and making this amp reliable. Okay, let's jump in here and fix the power supply on this little amplifier. It's not real hard and shouldn't take but a few minutes. These are our two big filtering caps. We're leaving this one alone. This is the one that needs to be replaced. You can see the power wire coming off pin 8 of the rectifier tube. Comes around, comes up through, and connects to this pin. So here's where the B plus comes into the amplifier from the rectifier tube. So first thing is, don't cut this zip tie. Just slide it down and take it off of those like that, because we're going to come back and we're going to reuse this. So the first thing we need to do is unsolder this big guy. And so we've got our soldering iron all warmed up, got our tip clean. We're going to put a little fresh solder on it. And I think it's easier to come in and unsolder this bottom one first. So put some heat on it and then pull that lug out. Then we heat up this top lug here. Just like that. I do want to say that you want to make sure that you've had the amplifier turned off for a good while, several hours anyway. And then you want to come in with a screwdriver. And I don't normally recommend this. You can use a resistor across here to drain these capacitors, but after a few hours, the voltage is going to be low enough where you can just go from here across to there, and you'll see a little tiny spark, and that drains the last little bit of voltage out of the caps before you jump into doing this. So the next thing we're going to do is we need to put this little cap across right there. And we really want this to be sitting up against this cap so we can tie it down. So go ahead and bend that lead over and get it shaped where it can go through that hole over there and still be up against this cap. And then we want to do the same thing with this lead. Just bend it up and over, something like that. And then we want to come in with our snippers and trim off these leads. And I do it off to the side so the little piece of the lead doesn't fall down inside the amplifier. And then we're going to do the same with this one right here. And then we simply heat this back up, slide it through, and then we do the same thing down here. We heat this terminal back up and put the cap through just like that. Let me make sure that it's got a nice good connection. We put the zip tie back around. We tighten it back up around the caps. And trim off the excess there. And there we go. We got the cap replaced. Make sure that you have the negative stripe on this cap going to this terminal right here, because this little wire going across here, this is your little negative bus that connects to here, that connects to the chassis ground down below. So the last thing we want to do is we want to put a bleeder resistor across this cap here. And so that resistor is going to go right across there between this terminal and this ground. And you can put it in several places. It might be easier to put it across here. That'll also work. But the main thing is you just want to have this 470K resistor across between the positive side of this big cap and ground. So I think we are actually going to put it right across here. And so we can, and this is different than I did the last time, but I think this is a little better place to put this resistor. So we're going to come in here, wind that around there, and then trim this off. And wrap this around this little bus right here. So now we got to do is solder this here and here, and we have our bleeder resistor in place, and we're done modifying the power supply on this little amplifier. And there we go, all finished. And let me zoom in here and show you what this looks like when it's all finished. So again, this is the positive side of this second cap, and we're putting this bleeder resistor from this point here up to this ground point right here. And again, you could put it from there to there, you could put it from here to there. It's all doing the same thing, just whichever way seems easiest to you. And then again, here is our 22 UF cap that's soldered from here down to here. And that's it. That's all there is to wiring up these power supply and fixing this capacitor problem with this little amplifier. So let's wrap this video up. Well, as you can see, that was a pretty easy process to fix the power supply on this amp and make this little amp reliable. So hopefully you got some understanding on how power supplies work, how tube rectifiers work, why this capacitor is a problem, and how easy it is to fix this. And again, this is another example of a made in China hi-fi product where this is a well-known problem and has been for years. And the manufacturer has to know by now that this is a problem with the amp, and it would actually save them money because the 22 UF cap is going to be cheaper than that big 150 UF cap is, and would make the product reliable. So, not sure why this thing's still being produced this way, but it is. And I hate to use the term fatal flaw, but that one cap is kind of the fatal flaw with this amp. You know, the rest of it is performance related, and I understand that maybe, you know, trying to understand how cascodes work might be beyond what the people that built this amp are capable of. I don't know. again, 2 resistors fix that, which we're going to do in the next video. So don't dive in, don't start ordering parts until we get through with the next video in this series, where I go into fixing the performance problem, showing you how I found that problem, and step by step how to install the resistors to fix it. So hopefully you're enjoying this series. That's a redo of my earlier 6P1 videos. If you are, please sub to the channel, please like the video, and we'll see you real soon when we dive back into more 6P1 fun. Have a great day.